Hi students, myself Kale SL, Rayat Shikshan Sanstha's RBNB College, Srampur, Junior College Mathematics Department. Today we start here 11th Science Mathematics Part 2, lecture number 1st and chapter 1st Complex Number. We will see here basic concepts. Now in the school level we have seen different type of numbers. Numbers are divided into two types, real numbers and imaginary numbers. Again here real numbers are divided into two types, that is rational numbers and irrational numbers. All we have seen, these real numbers we have seen in the school levels, that means natural numbers, prime number, composite number, whole number, integers, etc. All those numbers we have seen in school level. Now today here we have to see complex number, and before to learn complex number we must know what is imaginary number. So if we consider here root of minus 7, such type of numbers we have not learned still now. The numbers except this root of minus 7 are nothing but real numbers. So here root of minus 7 is the imaginary number. We express this as like this: root of 7 into, suppose this, minus 1. So this is equal to root of 7 into root of minus 1. And now we consider here root of minus 1 is equal to I, suppose. That is the imaginary unit. So I is equal to root of minus 1. So it is root 7 into I. And therefore this root 7I is called the imaginary number. Real numbers and imaginary numbers, we imagine this. So such a type of numbers are imaginary numbers which are in the form of I. So we know now here the numbers are divided into two parts, real numbers and imaginary numbers. So imaginary numbers means square root of negative number. Square root of negative number we can't take. So how to express this? So we express this root of minus 7 like this: root of 7 into root of minus 1. And then it is root 7 into root minus 1, and root of minus 1 write it as a I, and we call this I as an imaginary unit, and therefore we express this root of minus 7 is equal to root of 7 into I. This is called the imaginary number. Now complex number is, suppose denote it as Z, it is equal to A plus IB. Complex number is A plus IB. Here A and B, these are real numbers. A and B, these are real numbers, and I is root of minus 1. For example here 2 plus 3i, Z is equal to, suppose, 2 plus 3i. This is a complex number. Here 2 and 3, these are the real numbers, and that complex number is denoted by Z. Or we may take another example, minus 5 plus 7i. This is also a complex number. So this is the basic concept of numbers. Now here, what is the professional definition of complex number? We see here definition of complex number. Complex numbers. A number of the form A plus IB, or we may write A plus BI. We may write here A plus BI also. So a number of the form A plus IB where where a comma b belongs to real number and I is equal to under root of minus 1 with I square is equal to minus 1 is called a complex number. Is called a complex number, and it is denoted by Z. See here, a number of the form a plus ib, where a, b, these are nothing but the real number, and I is equal to under root of minus 1 with I square is equal to minus 1. If we square this equation on both sides, square this, we get I square is equal to, on the right hand side, root of minus 1 square, root and square get cancelled, so it is equal to minus 1, is called a complex number and it is denoted by Z. Thus here Z is equal to a plus ib. Get it? Here a and b, a comma b belongs to R and I is equal to under root of minus 1. Now here this a, we call this a as a real part, a as a real part, and the coefficient of b, it is called imaginary part, and we denote it by real, re, real part of Z, real part of this complex number, that is equal to a, or only we denote by R of Z, that is a, real part of Z, it is a, and imaginary part, that means this is the imaginary number, ib is the imaginary number we have just seen. So coefficient of I, that is the imaginary part of Z, and it is equal to b, or only we denote by I of Z is equal to b. So here a is called real part and b is called imaginary part. Imaginary part is the coefficient of I, and this ib is the imaginary number. Means here complex number, it is the combination of real number and imaginary number. Complex number Z, it is the addition of, this is the real number and this is the imaginary number. If we add a real number and imaginary number, we get the complex number. For example, here Z is equal to 2 plus 7i. In this we have real part of Z, that is equal to 2. Here real part of Z is 2 and imaginary part of Z, that is equal to 7, the coefficient of I. Or here suppose Z is equal to, second example, Z is equal to suppose 3 minus 7i. 3 minus 7i. Here real part of Z is equal to this 3 and imaginary part of Z, it is equal to this minus 7, coefficient of I. So this Z is equal to a plus ib, we denote in set notation also. Z is equal to set of Z is equal to here set of all a plus ib such that AB belongs to R. AB belongs to R and I is equal to under root of minus 1. So we denote Z is equal to a plus ib in set notation like this. Z is equal to a plus ib such that this vertical line is such that AB belongs to R and I is equal to under root of minus 1. So this is the basic definition or basic concept of complex number. Now here we will see algebra of complex number. Algebra of complex numbers. Here firstly we see equality of two complex numbers. Suppose here x plus iy is a complex number and it is equal to 4 plus 5y. These two complex numbers are equal. This is the equality. So left side and right side are equal if their real parts are equal and imaginary parts are equal. So this implies here x is equal to 4 because here real part is x, so x is equal to 4. Imaginary part means coefficient of I, that is y. Here coefficient of I is y and here coefficient of I is 5. So both are equal. Y is equal to 5. So this is the equality of two complex number. Now second here, addition of two complex number. Addition of two complex numbers. Suppose there are two complex number 5 plus 7i, this is one complex number, and another complex number is 4 plus 3i, and we have to take the addition of these two. 5 plus 7i plus 4 plus 3i, this is one complex number, this is another complex number, and we have to take the addition. Here we cannot take the addition of 5 plus this 7, that means we don't write here 5 plus 7 as a 12. This is the imaginary number and this is the real part. So we have to add real part plus real part of this plus real part of this. Firstly open the brackets, so we get here 5 plus 7i and plus here 4 plus 3i. We remove round brackets and now take here this real part and this real part, 5 plus 4. 5 plus 4 plus here 7i plus 3i plus 7i plus 3i. So 5 plus 4 that is 9 plus 7 plus 3 that is 10, 7i plus 3i that is 10i. So addition of two complex number is again a complex number. Addition of these two complex number is again a complex number. Here this is the 9 is the real part and 10 is the imaginary part. Now here next subtraction of two complex number. Subtraction of two complex numbers. Suppose here 7 plus 5i is one complex number and 2 minus 3i is another complex number, and we have to take the subtraction of these two. So here firstly open these round brackets, so we get here 7 plus 5i, this minus 2 multiply by minus, so minus 2 minus minus plus 3i. Now collect the real part, that is here 7 minus 2, this 7 and minus 2, and then plus this 5i and plus 3i, 5i plus 3i. So now here 7 minus 2 that is equal to 5. Plus here 5i plus 3i that is equal to 8i. So in this way we take the subtraction of two complex numbers. Means if we want to take the subtraction of two complex number, then take the subtraction of real part and subtraction of imaginary part. When we take the subtraction of two complex number, it is again a complex number. Here answer is 5 plus 8i, so it is a complex number. So in this way we take the subtraction. Now scalar multiplication, fourth one is suppose scalar multiplication. Now how to take the scalar multiplication? Suppose here 2 plus 5i is one complex number and we have to multiply this 2 plus 5i by any scalar, suppose k, or put k as a 3 suppose. So 3 into 2 plus 5i, that is a scalar multiplication of a complex number. So this is equal to multiply by 3 inside the bracket to every term. So 3 into 2 plus 3 into 5i. So we get here 3 into 2 that is 6 plus 3 into 5 that is 15i. So this is the required complex number. So to take the scalar multiplication of a complex number means multiply by scalar to real part and into imaginary part. Then we get here scalar multiplication. It is again a complex number. Now here next one is conjugate of a complex number. Next we see here fifth one, conjugate of a complex number. Now it is very important. Suppose 3 plus 2i is a complex number. Then what is the conjugate of this complex number? So its conjugate we find by changing the sign of imaginary number. We change the sign of imaginary number 2i. Here 2i is plus. So if we take minus, then it is the conjugate. So its conjugate is 3 minus 2i. We change only the sign of this 2i. 2i is plus, take minus. So 3 minus 2i is the conjugate of 3 plus 2i. Or we may say here 3 plus 2i is the conjugate of 3 minus 2i. That means these two numbers are conjugates of each other. Suppose here 7i plus 8. 7i plus 8. Then its conjugate is change sign of only imaginary number. Change the sign of only imaginary number. Here imaginary number comes firstly, so change its sign only. So 7i here become minus 7i plus 8 as it is. This is the conjugate. Or here 5 minus 2i, this is the complex number. Then its conjugate is change only the sign of 2i. Here 2i is minus, take plus. So here it is 5 plus 2i is the conjugate. In this way we can find the conjugate of every complex number. Now here multiplication. Next, multiplication. Now if we want to take the multiplication of two complex numbers, suppose 3 plus 2i is one complex number and another complex number is 3 minus 2i. See, now these two complex numbers are complex conjugate of each other. Terms are same, here 3, 3, 2i, 2i, but here only plus, here minus, so conjugates of each other. And we know that if a plus b into a minus b, it is equal to a square minus b square. This is the formula. A plus b into a minus b, it is equal to a square minus b square. So we direct use here formula. So it is equal to 3 square minus b, b is here 2i square. So it is equal to 3 square is 9 minus 2 square is 4 and I square, here I square. We know that here I is under root of minus 1. I is under root of minus 1 and therefore I square is equal to root of minus 1 square. This square and square root get cancelled to each other and therefore I square is equal to minus 1. And therefore we get here 9 minus 4 and I square is minus 1. And so it is equal to 9 minus minus plus 4. 9 plus 4, that is equal to 13. So here multiplication of any two conjugate numbers, multiplication of any two conjugate numbers is a real number. Now here again we take next example. Suppose here 2 plus 3i and another complex number is 3 plus 2i and we have to take the multiplication of these two. So here we multiply by 2 to this bracket plus 3i to this bracket using our previous method. So this is equal to 2 into, so right here 2 into 3 plus 2i suppose, and plus then this 3i and again write this bracket 3 plus 2i. So it is equal to 2 into 3, that is 6, plus 2 into 2 4i, plus here 3i into 3, that is 3 into 3 9 and I, plus here 3 into 2 6 and I into I square. So it is equal to this 6 as it is. Now this 4i plus 9i, we add this 4i plus 9i, that is 13i. 13i. Here plus 6 as it is, we know I square is minus 1, just we have seen. So 6 into minus 1, and so it is equal to 6 plus 13i, and this plus minus become minus 6. This minus 6 and plus 6 get cancelled. So we get here 13i. So in this way we can find the multiplication of any two complex numbers. Now next here, powers of I, very important concept, powers of I. Powers of I. We know that here I is equal to under root of minus 1, and therefore this is I's first power. Here power is 1, so I is equal to under root of minus 1. We take here I square, that is second power, so it is equal to root of minus 1 its square. Now this square and square root get cancelled, so it is equal to minus 1. Now we find here I cube, I to the power 3. It is equal to, we write this as I square into I. We split this 3 as 2 plus 1. Using the rule of indices, in the base there is multiplication, so we add the power 2 plus 1, that is 3. Now here I square is minus 1, so it is minus 1 into I, and so it is equal to minus I. Now I to the power 4, I to the power 4, it is equal to, we write I square to the square. We write this 4 power as 2 to the power 2 using the rule of indices, and we know that I square is minus 1, so it is minus 1 to the power 2, because I square is minus 1 and this 2 as it is, minus 1 square, that is positive 1. So I to the power 4 is 1. So remember always here I is equal to under root of minus 1, I square is equal to minus 1, I to the power 3 is equal to minus I, and I to the power 4 is equal to 1. These are the powers of I. Now here we have seen equality of two complex number, addition of two complex number, subtraction of two complex number, how to find conjugate of complex number, multiplication of complex number, and powers of I. Now only division is remaining. We see this division while solving the problem. So in this way we have completed here all the basic concept of the complex number. Now let us start here exercise 1.1. Exercise 1.1. Simplify. First question is simplify. Simplify, and first problem is under root of minus 16, under root of minus 16 plus 3 into root of minus 25, minus 25 plus root of minus 36 minus root of minus 625. We have to simplify this problem, means we have to find the value of this. We know that square root of negative number is the imaginary number. We have seen in basic concept. So we express this solution of this root of minus 16 plus 3 under root of minus 25 plus root of minus 36 minus root of minus 625. Write the question again in answer. First step. So this is equal to, we write this as root of 16 as it is into root of minus 1. Here root of minus 16 means it is root of 16 into minus 1, and separate the roots, root 16 into root minus 1. So we write here root of minus 16 as root 16 into root minus 1, plus here 3, here also write root of 25 into root of minus 1. Here also write root of 36 into root of minus 1. And lastly here minus root of 625 into root of minus 1. Now we know that root of 16 is 4. Root of 16 4, and we assume this root of minus 1 as I. We know that I is equal to under root of minus 1. That is the imaginary unit. So this root of minus 1 is I, plus here 3. This root of 25 is 5. So 5. Root of minus 1 is I, plus root of 36 is 6. Root of minus 1 is I, minus root of 625 is 25. Root of minus 1 is I. So it is equal to 4 into I, 4I, plus 3 5s are 15I, plus 6I minus 25I, it is minus 19I. This 6I minus 25I, 25 minus 6, that is 19, and sign of 25 is minus. Now here 4 plus 15, 4I plus 15I, that is equal to 19I. So 19I minus 19I, same number, subtraction of same number, so it is equal to 0. So the value of this problem is 0. So in the solution, or again right here, this is equal to 0. So in this way we have solved here first problem. Now second problem. Second here, 4 into under root of minus 4 plus 5 into root of minus 9, 5 into root of minus 9, minus 3 root of minus 16. We have to find the value of this. So solution of this, 4 into under root of minus 4 plus 5 into under root of minus 9 minus 3 into under root of minus 16. In the solution, again write this step question as it is. So it is equal to 4 as it is, and we express this root of minus 4 as under root of 4 into under root of I. Here plus 5 as it is, write this root of minus 9 as root of 9 into root of minus 1. Now here this minus 3 as it is, write this root of minus 16 as root of 16 into root of minus 1. And so this is equal to this 4 as it is, root of 4 is 2. Here root of minus 1. Here root of minus 1. And now this root of minus 1 is I. Plus here 5, root of 9 is 3. And root of minus 1 is I, minus 3, root of 16 is 4, root of minus 1 is I. So it is equal to 4 2s are 8I, plus 5 3s are 15I, and minus 3 4s are 12I. So here 8I plus 15I minus 12I, that is 3I, and 8I plus 3I, that is equal to 11I. This is the solution of the second problem. So again write here, hence 4 into under root of minus 4 plus 5 into under root of minus 9 minus 3 into under root of minus 16 is equal to 11I. This is the final solution. So in this way, here we have completed question number first. Now question number second, write the conjugates of the following complex numbers. Question number second. Question second, write the conjugates of the following complex numbers. First example 3 plus I, then second example 3 minus I, second example 3 minus I, third example here, third example minus root 5 minus root 7I, fourth example here, fourth example minus root of minus 5, then fifth example here 5i. Sixth example, root 5 minus I. Seventh example, root 2 plus root 3i. Root 2 plus root 3i. And eighth example here, cos theta plus I sin theta. Cos theta plus I sin theta. Now we have to write the conjugates of these complex numbers. Answer is in one line. Its conjugate is, we write here, its conjugate is, only we change the sign of imaginary number. Change the sign of I part, that is imaginary number. So here 3 minus I is the conjugate. Here its conjugate is, we write here its conjugate is, change the sign of I, here minus I, so 3 plus I. This is the conjugate. Here its conjugate is, here minus root 5 as it is. This minus become plus. We have to change the sign of imaginary number, so plus root of 7i. Now here firstly we have to write this equal to this. This is in square root minus 5. So minus root of 5 into root of minus 1, and it is equal to minus root 5 into I. Minus root 5, and this root of minus 1 is I. And then we write its conjugate. So its conjugate is here minus sign, so it is plus root 5i. Conjugate is plus root 5i. Now here its conjugate is, change the sign of this imaginary number. Here it is plus, so it is minus 5i. Now here its conjugate is, change only the sign of I. Here minus, so take plus, so root 5 plus I. Now here its conjugate is, change the sign of this imaginary number, that means root 2, here plus, so take minus, so minus root 3 into I. And the last one, change the sign of this imaginary number, so its conjugate is, cos theta. We change this plus as minus I sin theta. So in this way we get the conjugates of all complex numbers. So we have completed here question number 2 also. So in this way we have seen in this lecture the basic concept of complex number, and also we have completed question number 1 and question number 2. So today we stop here. Thank you.